to find the final speed of the snowboarder, we must use conservation of energy in order to find that. The equation of the conservation of energy is 1/2 mv squared plus mgh equals 1/2 mv squared plus mgh. And we have to add an I here to show that this is the initial speed and height of the snowboarder, and F here to show that this is the final speed of the snowboarder and his height. So this is called the conservation of energy equation. And what this shows is that it shows that the snowboarder's initial energy is equal to his final energy, and by knowing this we can calculate his speed. So here are some of the information we're given. We're given that his initial speed is 2 meters per second, so we'll figure that in, 2 squared. We know that the height is 50 meters, so we will sub that in right now. And we also know that gravity is 9.8 meters per second downwards, which is g here, and I will sub that in also. 9.8 equals 1/2. Now we don't know the final speed, and that's what we're going to find, so we just leave that as it is. And we also know the final height of the snowboarder, which is 25 meters. 25. Now the g here is 9.8, so it's the same as the g over here, so I will also sub that in, cross this out, and sub this in. Okay, now we know this, the m is not given, the mass of the snowboarder is not given. However, we can see that m presents in both sides of the equation. Therefore, we can cancel it out, and it's not needed. Now we're going to calculate. So, times 4 plus 50 times 9.8 is 490 equals 1/2 v squared final plus 25 times 9.8. And 1/2 times 4 is 2 plus 490 equals 1/2 v squared final plus 245, which is 25 times 9.8. Then 492 minus 245 equals 1/2 v squared final, and 492 minus 245 is equal to 247, and we shift the 2 to the side of the equation and it becomes a multiplication instead of a division. So 472 times 2 equals v squared final. And then we find the product of the multiplication, which is 494. That equals to v squared final. And then we square root the product. And what we get is 22.23 meters per second equals v. And that is the final speed of the snowboarder at 25 meters per second. We write a therefore statement. And the question is done. second question, we are still at the same height, so delta D equals 25 meters. But there's another component that's in place, which is the coefficient of kinetic friction, mu k, and the coefficient is 0.02. And now assume something different. The initial speed of the snowboarder will be increased to 5 meters per second. To do this question, we have to know that Ff, which is the force of friction, equals mu k, which is the coefficient of friction, times Fn, the normal force. So according to Newton's first law, any force is made up out of F equals m times acceleration. According to Newton, any force is made up of mass and acceleration, and mass times acceleration equals force. This also applies to the force of friction and the normal force, which is of Fn. So therefore we can write Fn as mass times gravity, because gravity counts as an acceleration force, and it's the only acceleration force that any object receives when it's in touch with the surface. I'll draw a diagram to clarify. So for example, a box is laying on a table, and the only force it receives is Fg, so gravity, and there's a normal force that's opposite to it, and these two force balances, so the box stays on the table and it won't fall to the ground or fly into the sky. So therefore we can find that Fn equals Fg. Back to the question. So therefore we can write the force of friction like this. Ff equals mu k mg, and mg here is normal force. And then we can do acceleration equals negative Ff divided by m. Because gravity is a negative force, negative 9.8 meters per second squared, to move it from this side to the other side here, you have to change sign, but we want acceleration to be positive, therefore we change this side to negative. So acceleration equals mu k times g, because Ff can be written as mu k mg, and mu k mg divided by m, so the m's cancel out, and mu k times g equals acceleration. I'll write it out just to clarify. Mu k mg divided by m. So m and m cancel out, and we have this here. And we sub in our knowns. So A equals mu k, which is 0.02, times gravity, 9.8, because here's, we already have a negative, sorry, just to add this in. And because here we already have a negative, we do not need to include another negative here, or else the sign would be wrong. And what we get is 0.196 meters per second square. And then we use one of the big five equations. Vf squared equals Vi squared plus 2a delta d. This means that the square of the final speed equals to the square of the initial speed plus 2 times acceleration times the change in distance. And since we do not know the final speed, we'll leave it here, and we sub in what we already know. Vi equals 5 squared plus 2 times, here is our acceleration, negative 0.196, and times the changing distance, 25 meters. And then we plug our thing in, 25 plus 50 times negative 0.196 equals 25 plus negative 15.2 equals 9.8 meters per second. And this number is the final velocity squared, and to calculate the final velocity we have to square root this, so 9.8 square root equals Vf, and the answer we get is 3.13 meters per second.